Hi guys. Why don't we have viewers? I need at least 10 to share my screen. No, I won't start it right away. We need 10 viewers or 10 likes or whatever. Have grapes to eat. Guys, 10 viewers. It shows 9. Also likes, you guys are not liking it. See, I should have incentive, right? Some incentive to come here and do this shit. Mm, yeah, it seems we have some viewers now. How am I doing? Varshit Vankadari. I'm doing good, Varshit. Hi, smart. We have 18 viewers though. But I did not know, but I solved two problems. But in third question, don't spoil the contest, okay? Don't spoil the contest. Like the video and we will give virtual, okay? She looks just like a dream, the prettiest girl I've ever seen. Cover up a magazine. I'll do 1-4 or something like that. I don't like why you guys do that to me. I'm using this hand and then I have to eat with this hand. Eat with left hand. I'll keep my grapes over here and eat with left hand. So guys, what should I go with? Is not important. How many did you solve is important. So I started a poll. Check that out. Don't spoil questions to me. So we have someone who did 4 problems. I haven't gotten any tips for first year students. First year students should probably explore what he can do and think from himself. Think for himself, sorry. Not think from, think for himself. You have to think for yourself, okay? I'll do Q1 and then I'll go for Q4, okay? I just don't want to start from behind. You're given it's an easy problem, it seems. It's glows. The color is nice. It's like cyan color. But they shouldn't keep these tags, okay? You're given a string S and an integer K. Reverse the first K characters of string S and return the string. How do we do that though? Would swap work? If I less than k minus I minus 1, k minus 1 minus I. So these are the two things that should be swapped, right? When I equals to 0, these two should be swapped. Swap of s of I comma s of k minus I minus 1. This would do the job, I think. Right. She looks just like a dream. What are we doing? Why did I use this if condition? I only want to swap once. If I swap twice, they will be swapped, right? So let's verify. It seems to be working. So submit. 999. Now let's go to Q4, guys. Okay. Is it hard? It's hard. Let's read the problem. You're given a string array grid of size n, where each string grid of I has a length m. It's either this or this. Cell is either available or is blocked. You want to count the number of different routes to climb grid. Each route must start from any cell in the bottom row, row n minus 1, and end at the top row, row 1. So it has to go from here to there, it seems, okay? However, there are some constraints on the route. You can only move from one available cell to another available cell. The Euclidean distance of each move is at most d. How can Euclidean distance come into picture? I think if it is coming into picture, it is not much related to grids, right? I think it's some brute force thing. Where d is an integer parameter given to you. The Euclidean distance between two cells R1, C1, we know what an Euclidean distance is. Do you guys know when was Euclid born? Like Euclid timeline. It's even BC, 300 BC, and we have folks thinking they are smarter if they were born earlier. Like if some people really think if they were like born in like 1 century ago, they would be doing great because they are so smart. They think people got them smarter. Now we just got some technology, I guess. Egypt, it seems. We have division algorithm. I mean, division Euclid division algorithm. I don't know what it is. Yeah, probably that. Each move either stays on the same row or moves to the row directly above from R to R minus 1. What does that say? Okay, so it can go to R to R minus 1. Columns can be anything. Columns can be anything, but the distance must satisfy. Okay, this actually says you only have a window above that. You only have a fixed length window. So now Euclidean distance was just some thing in between. You should just say R1 minus R2 is just 1. So it is root of 1 plus C1 minus C2 whole square. With this less than or equals to D. With this you have 1 C1 minus C2 length. To what cells you can go, okay? So these two combined just says that if you are in C1, let me read the problem and then let me come back to that again. You cannot stay on the same row for two consecutive runs. You have just told me that. Wait a minute. Wait a minute. Okay, you can stay there or you can move above, but you cannot stay on the same row for two consecutive returns. If you stay on the same row in a move, and this move is not the last move, your next move must go to the row above. What the fuck does that mean? You cannot stay on the same row for two consecutive turns. What is a turn? Try to move. What is a turn? Maybe. I don't know. Maybe that is a turn. So after a turn, you move there, and then again you should not move there. So means I think you cannot stay on the same place three times. Is it like that? If you stay on the same row in a move, and this is not the last move, your next move must go to the row above. Okay, why this came is because otherwise it seems like you must move to the next, right? That seems wrong. So they mean if you have stayed here once, you should not stay there again. Okay, you had a choice, you can stay there, but if you have stayed there, so we can either go up or you can stay there. And if you stay there, you must go up in the next time. Return an integer denoting the number of such routes. The answer may be very large, written it modulo. So we have to see the problem from above. We have these things already, some available, some unavailable. That makes it like brute force. Like there is no great algorithm that there is no importance to which cells are marked and which cells are not marked. Why? Why is there no importance? Because you cannot think of a simple algorithm that says, okay, the diagram shape is this, so this many number of. It is not like that. So it is likely brute force. What I mean by brute force, the importance of this and this is brute force. Like you don't consider any structure in this or not. You just try to brute force all of. I mean, this or this doesn't matter. Like is what I mean. What I'm trying to say is. Uh, Problem seems like it's something like brute force one, okay? So you have to brute force in a nice way. Let's say you have some constraints. I don't want to use dp term because it's overused. How to learn DP? It's like induction. Haven't you learned induction in school? DP is induction. That's it. Maybe some. Okay, now you want to write a program. Program is having all the time loops, right? So how many different routes? If you stay the same, is that counted as a different route? I think it should be counted as a different route. Let's check the algorithm. Let's check an example. Two routes are 1, 2, or two routes are 1, 2, and 3. What I'm trying to see is if you stay at the same place, even that is counted as a route or not, is what I'm trying to see. What I mean is if you stay here, if you move here, or if you stay and move, or those two different things is what I'm trying to say. I don't think they're different. Otherwise, we might have here 1, 1, 2, right? We might have here 1, 1, 2 instead of 1, 2. We might have 1, 1, 2. You can stay on the same row, but if you stay on the same place, that is like wrong. Okay, I mean that is not a different route. Route is nothing but what are all the cells you will visit, I guess. Okay, if you are here staying there, it doesn't count, but moving somewhere else might count, but you cannot do that twice. So how does it go, guys? How would it go if you try to write a general structure of some root, because you want to count roots, right? To count roots, try to write a general structure of how it's like, how it's how a root is. So in last row, it might have one C1, C2. C2 is like optional, let's say, okay. And then it will have, in row n minus 1, it will have again some C3, C4, let's say. So at max, this is it. This may or may not be present, but at max, this is what it can do. So you have to track. So if you want to write this in a general way, because you're coming from below, right? And once you come here, it doesn't matter how many moves it takes to go from here to there. Everything is small. I think so. We have to brute force it. Okay, we are going from this row to this row. So when you are in this, so if you know number of ways to go from this to here, can you find number of ways to go from here to here? What I mean is, because n minus 1 to, there is a direction, a clear direction, that from n, all the routes that start from c1, and then go to c2, and then go to the below row, all those routes will take either this or something. So all such routes, you can just see c1, c2 is just on the top. After that, the problem is same as starting from here or here or here, and then trying to go to row 1. And if you go to row 1, it's end, I guess. Okay, it doesn't ends. It can just go there and it can stay there, okay? Because we have 1, 2, 3. So here 1 2 is possible, 1 2 3 is possible, 1 2 3 is possible. So I have a doubt. Can you do any number of moves in final round? You cannot do that. If you can do that, it will be infinite moves, right? Infinite number of paths, right? Because you can keep doing that. So even at the last place, you can only do two moves. Let's assume that. Otherwise, you can do 1 2 3 2 3 2 up to so on, right? So guys, there are two kinds of moves. Okay, uh, there are two kinds of things here because we have this limitation that you can only do twice. If you are in a row R and column C, if you can start from here, how many moves do you have? How many ways? How many routes? Starting from here, how many routes? Okay. Another thing is starting from here, you must move down. How many routes? If we have these two things, we can do it. Okay. In this case, we are allowed to go to something else and then we must go down. The same rules we follow. In this case, you don't even have that. You must go down. Why are we trying to split these two in these two cases? Because even this thing comes down to this thing, right? Even that thing comes down to, so that thing can be split into going immediately down and going to something here and then immediately down. Okay, so if you already have going to here and immediately down, you can get going immediately down directly. So till here, if we are clear, that means we have solved the problem. We have almost solved the problem. Okay. Any doubts here, guys? I don't think it's that difficult. I haven't dedicated any hours. Grapes. Do you call grapes as junk food? You can find my LinkedIn. Is this clear, guys? We have these two types of states, let's say. Starting from here, you must move down. Starting from here, you can do one more thing and go down. You need not. Okay. Now, so how do you solve this problem? You have some allowed range in below. You have some allowed range in row in below in row r minus 1. You just get some of that range and then you're done. If you get the sum of, because you can go from this range, right? You must go down. So that range is possible to go down. Or that's just answer some of that range. What about here? Same. You can go down. So sum of some range in row I r minus 1, or sum of some range in same row r but must go down things, because you cannot do twice, right? And how do you initialize these things? If rho equals to 1, if rho equals to 0 or 1, if you must go down, it is one route. You're already, you cannot go down further. Else you can go to something else in the same row, or you can just stay there. Okay. I mean, or you can, or not, you can stay there, or it's ended. So if it is same row, what is the allowed range? It is plus d to plus d, right? If it is different row, what is the allowed range? If it's a different row, the allowed range is 1 plus uh, d1 square less than or equals to d square. D1 square less than or equals to d minus 1 time or d square minus 1. We want biggest number less than or equals to this. D1 less than or equals to square root of d square minus 1. So you have to take floor division of that. Okay. And d1 equals to, I think this takes floor division. So it works out. Sqrt of, yeah. So we have d1. Okay. Now I have to initialize. So we have two types of arrays, right? Uh, can stay, I will call one as can stay, comma, must go down. Okay. Number of ways where you can stay, but you can only stay once. On these things, number of ways you can stay, but you must go down. For row 0, first we will do must go down. Okay. First we will do must go down. Okay. Must go of I mean 0 of I equals to grid of 0 of I equals to hash, means 0, else it is 1. Okay. Now you will try to do this thing. You'll also have prefix sums, let's say, for both of these things. Okay. Let's also just pref can. Let's just also have prefix sums. Okay. Pref must, because we need prefix sums at sometimes. If I must go of, I'll make it prefix sums. Okay. All the dust, bacteria from my keyboard directly going to my mouth. I'm trying to make a prefix sum of this thing. Okay. Okay, that was weird, but fine, yeah. So now what? From here, what is the range that is possible? What is the range that is possible? R minus D to I plus D inclusive, right? This is the range that is possible from here. Okay. I'll just use some other function to get me prefix sums, okay? Uh, int get sum, it takes some range, okay? It also takes m, it takes int star pref, let's say. Okay. It makes L equals to max of L comma 0, R equals to min of R comma m minus 1. Okay. return pref of r minus L equals to 0 means 0, else pref of L minus 1. So this should be fine to get sum, right? So now what it does, can stay of 0 of I equals to, so you either stay here or you go down, okay? So it's a bit confusing. We are not moving from here to here, okay? We are not moving from here to here. We are involving just staying here, and we are involving going from here to somewhere else, so we can just get the sum. We need not subtract the middle one. We should subtract the middle one actually, but that middle one is getting added by, because we are considering both, it's getting added, okay? You have to be careful here, guys. Be careful about that. Do you guys get what I meant? What was the name? Oh, can I make themselves, can I make them itself as prefix arrays? If I make them itself as prefix arrays, I think that's all, that also works. I need not have a new prefix array. So this is nothing but sum of must goes plus staying there itself. That was must go, okay? She looks just like a train. So now we are here. First we will find must go like before. If s of I equals to this, then there is nothing. It's just 0 and you can continue. Else from here you must go down. Because you must go down, what will be the answer? Get sum of I minus d1 comma I plus d1 comma m comma must go of I minus 1, okay? In the below row you can take anything. If you want, I can draw. So you must go down, and in the down this is the range you have, okay? So that's the sum. And then what would you do? Let me also written modulo here. Can I make it bigger? Now where are we? Yeah. Now we want can stay sum. It can, this involves like you're going down from here or you're staying somewhere here, okay? This involves two things. I have to first make this as prefix array, okay? I can do here itself, but I don't want to confuse you people. So here again it's the same thing, like just like above. Did I do that here though? I should do that here too. She looks just like a dream, prettiest girl I think it's being boring, guys. Like the problem is very boring, or I'm being too slow. I don't know. My videos are difficult to watch. I think I don't know how you guys do. I want to quit this shit actually, but I'm not able to much. I'm not much able to do this. Sometimes thinking. I mean, I say that all the time. It looks like I'm just trying to get some response from you people, but so this is must go of row, the same row. This is row minus one. Okay, but this is the same row. Why? That involves going to some here and then must go down, or just going down from here. She looks just like a dream, the prettiest girl I've ever seen. So if you have done all these things, now we are done. So now what would be the final answer? Because we are anyway doing prefix sum, final answer is nothing but should we do long shit? Should we do long instead of everywhere? So let this two be long. Let this two be also long. Let this should be long too. She looks just. In answer equals to. Let this be long too. Can stay of n minus 1 of m minus 1 because that involves all the summation, right? Because we are doing prefix array. So this should work, but it will not because we have been careful. We have been a bit careful, but the fuck you mean by that? Will this syntax work? She looks just like a dream. In the dark, cruising around with you, my baby. You know that I got you. So is this vector of vector int? We have 1 1, we have 2 2, we have. What is answer here? 0. Should I submit and check? Can I check on these test cases? How to add a new test case? Copywriting even a test case. Fuck. Shitty interface this is. We are getting 4. That seems correct. This seems correct too. Why did it separate? Okay, we have a case where it is 4, right? Where is it 4? Here it is 4. So this is being wrong. This should have been 4, right? 1, 2, 1, 1. Let me print and see. I think if you print must go, we can see most of the things. So this was 1 and 2. And what is D1? D1 should be 2 at least. Root of 4 square minus 1. D1 should be 1 at least. Oh, even now it didn't change. Have I been careful here? Yep. Yep. So D1 was 1. So why hasn't this must go thing have been added? Like why hasn't this must go thing gotten this to sum? We have to see that. Because I think we have to do this R R. But why didn't this must go thing has gotten the previous thing's summation? I think it has gotten. That is 2. And this is 0. Wait a minute. This should be can stay. This should be can stay. Because after you go there, you can stay there, right? This is must go. And the can stay summation you had before, that will be covered. So should we see other test cases? Wait, it's so shitty interface. You cannot scroll here, you cannot scroll here, you cannot scroll here, you can only scroll here. What is that shitty interface? Should I have done lesson? So if d equals to 1, what's happening now? Why can't I edit this? In future, they will ask to pay to edit a test case. Guys, the problem has been done, but I'm not able to see what's the error. Where is my hair? It's gone. Like the video, guys. I'll try, bro. But that doesn't change this answer. Dun, 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 dun. So d equals to 5 and everything is active here. In that case, we are giving wrong answer. But only very few have passed somehow. Only very few have failed. This is the shitty interface ever. It was better a few days ago, I guess. I have understood the problem well, I guess, because we have seen some test cases too. Dun, 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 dun. If you go down, you can stay there too. Didn't even find any error. I struggle randomly. You cannot say that. Didn't even find some error. What the fuck you mean by CF every 1900 plus problem requires DP optimization? I've done so many code forces problems without DP. What do you mean by every problem needs DP? Like, is this problem DP? This is not DP. But is this DP? I don't think DP. This is 2700 and that's not DP. But if you see some other problems, not every problem is DP. Don't make stupid assumptions, okay? Try more. Try to see the truth, okay? Can anyone help me with this? Like, is there any error here? Written it modulo 1e9 plus 7. Why did I do that? I thought I have seen it somewhere. I thought I have seen the other thing somewhere. I thought I have seen 998244353 somewhere. I don't know who has implemented this thing, like being able to merge these two things, like moving this thing to this. Who has done that? I don't know, like, but it's very shitty. It's like very shitty interface. There is no place to scroll. What the fuck? Okay, this seems a lot better. This seems a lot better. Focus mode. So now we are in focus mode, guys. We have to do problem 3 and 4. You're given an integer n. It seems like the same problem. A 2D array and an integer array diff of length n minus. And your task is to construct a sequence of length n denoted by a0 is 0. All elements are non-negative. Every index I absolute of I minus absolute of a of I minus a of I plus 1 is not equals to diff of I. For each, see, you have to see every problem as a new problem, okay? How to solve the problem for the problem. Don't see what you have to use, maybe how to use DP, maybe how to use something you don't know. It's never like that. CP is, everything is in the problem, okay? For every integer index I, absolute value of this should be less than or equals to def of I. So you have some restriction that this minus this absolute value should be less than or equals to some particular value diff. For each restriction of I equals to the val at position idx in the sequence must not exceed max val. So we have these restrictions to additional restrictions, it seems. Your goal is to construct a valid sequence that maximizes the largest value within the sequence while satisfying all the above conditions. Return an integer. So this is this DP? We don't know. We have to see properly, okay? They cannot vary much. They cannot vary much. And you have to attain some maximum value. Oh, this difference is less than or equals to 10. So you have to see this one. See, if this was 10 power, very big value, the problem is different, right? But this difference is less than or equals to 10. And what about n? N is less than or equals to that. Max values can be less than or equals to 1e6. You have how many restrictions? Many restrictions. And these indices are unique but they are not complete. This seems like a difficult problem, but is max value fixed? I don't think max value is fixed. Def dot length equals to n minus 1. All of them are non-negative. Can you always try to greedily keep maximum possible from 0? Is that always better? Because you have restrictions that your goal is to increase. You have restrictions that it should be below that. And if you have a very big restriction, then you cannot have it here until you can have it from here to here. Look at all the restrictions. Maybe there is a range possible for each of them. It's not that easy. I'm not getting it at all. Because if there is something I plus 1 is like very small because of the max value restriction, and you cannot greedily have it very high because then it has to come down so that the max value will be satisfied. How do we solve this? How does diff less than or equals to 10 help? I don't think it helps because plus 10 plus 10 plus 10 it can go forever, right? Let me read Q2. You're given an integer array nums on integer k. Return the minimum length. I think I need water. Return the minimum length of a subarray whose sum of the distinct values present in the subarray. Maybe you can binary search on the length. If you take everything, if it is possible, if it is impossible, even if you take everything, it's minus 1. Okay, but if you are taking something, so binary search and so binary search on length, and for each length you should be able to say if there exists some of distinct values, right? Maybe how do you make distinct values? Maybe if you make that one 0 and this one as when a new thing comes, maybe if you make the previous thing as 0, let's say you have 2 here and 2 here. Let's say you have 2 here and 2 here. I mean, now we have the problem which is to, now we have the problem given a length. Okay, sorry, given a length z, how to get sum of k, sum of distinct values in this window. We can obviously use some multiset or something like that to do this thing. I mean, we can maintain their frequencies based on their frequencies. We can try to see, we can add them to a set, and we can maintain the sum of that set. What I mean is, if it is present, try to keep it aside, and all the distinct values you're keeping aside, their sum you can get. You can get their sum, and you can do like sliding window. But if you have two here, again two here, and so on, and you're trying to calculate for this window, okay, can you make this as 1 0 and this one as 1, so that when you're here, from here only the last occurrence will be active, and then you will see from here you will try to see the prefix sum. I mean, using prefix sum you can try to see this sum, if that sum is greater than or equals to k or not. Okay, I think that just works. Okay, when you are here you have to make this 0, you have to make this 1, but then you have to update the whole prefix sum. That's not possible with prefix sum, so you have to do range addition or something like that to do that, but that's not possible. So what should we do? I think we can just add it to some set, maybe some multi-set, and count that multi-set, okay? So what is one problem is bool check. Let's say length with a value. Is there a subsegment whose length is L and total sum is greater than or equals to K? Let's just maintain a multi-set so we know when to remove or something. Okay, we'll try to do this like, we want multi-set, we want to have a multi-set, and we want to know, maybe we can just do frequencies. We'll just do set and frequencies. because values are within 1e5. Mm, if frequency of val equals to 0, then it's a new one, right? Or 1. Let's do frequency of val plus plus. So frequency will have number of things in this range now, okay? If that is 1, we have to add to sum. So now we have that sum. If sum greater than or equals to k, return true. So now we have to start from I equals to 1, I equals to L, I less than n, I plus plus, nums dot size of I plus plus. Okay. So we have to remove I equals to L minus 1 now. I equals to L, we have to add I equals to L. So we're trying to add I equals to L. Frequency of val equals to nums of I. Okay, we have added this thing to that to that. Okay, now if frequency of val equals to 1, that means it's a new thing. Sum plus equals to val. Okay. Now you have everything. Now you are trying to remove nums of I minus L, let's say. Okay. Frequency of val minus minus. If frequency of val becomes 0 after that, then only we have to subtract that. Okay. Now you have sum. If sum greater than or equals to k, return true. Return false. So this is O of n. It's like not even log n. We are not using any set 2. We're able to maintain frequencies. I'll try to make all the frequencies zeros after that. In the beginning, I'll try to do that. So what is this? We are adding something. Only if it was new, then we have to add it to that. Okay. When we are subtract, I think it's better if I keep it here and keep it as 0. Then we have this stack kind of thing because 0 plus plus minus minus 0. It was not present. After removing, it has been removed. So that's why we are doing that. So now we do binary search. But before binary search, we can do if check off nums comma n comma k equals to false, return minus 1. Okay, else what is possible? Left be 0. Okay, right be n. N length is possible. Okay, now we are trying to find what is the biggest length that's possible. If mid is possible, then right will be made, else left will be made. And what is possible is answer right, and right is possible. I'll submit and see. I don't have time for this. Only Q3 is left, and I don't know how to do Q3. Can someone help me with Q3? It seems difficult for me. How is this difference of it restricts a lot and then the max value restricts again? Bam, ba, na, 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 na. Okay, one thing is clear. Loss value is either the max thing or something that is restricted plus absolute differences. Loss value will be of that form because otherwise you can keep increasing that. That we can say. It is tight at some place. How does difference less than or equals to 10 help? Help me, guys. One forward pass, one backward pass. I haven't used such algorithms much. I don't know how to prove them. Maybe we can prove them. Should I not learn? Should I not learn and just leave it like that? One forward pass and one backward pass. But how do you do a backward pass? Trying to keep the value at max. I'll try whatever that guy has told me. I'll try to do something called forward pass, which would be trying to maximize that by only considering this side, okay? A of I equals to min of I minus 1 plus def of I, comma, max var of I. So what is it trying to do? It's trying to increase, okay? But if max value is too low, this might be too above. Now we come from this side and we try to reduce them, okay? N minus 2 I greater than or equals to 0, I minus minus. If a of I minus a of I minus a of I plus 1 greater than def of I. This is def of I minus 1, I think. We'll reduce a of I. I don't know how this shit works. This should be wrong. I hope it is correct so I can sleep peacefully. But how, guys? How's that? I have never done such a problem. I mean, I have done maybe long back, but I would not try such things in general. I would not try such things. I'm still not able to understand very well. Trying to maximize as much as you can, but something can be too low. Now try to reduce them again. How can you prove that that algorithm works? We are respecting max vals everywhere, okay? But we are not respecting some. We're respecting max vals. We are respecting AI min. Okay, this is absolute, right? Which is nothing but two things. So this is nothing but this thing, and which is nothing but a of I plus 1 and a of I plus 1 minus a of I less than or equals to def of I. So what we were doing was initially a of I less than or equals to max val. We were respecting two things. We were respecting these two things and we kept this condition aside. So we were respecting only these two things, which is nothing but a of I plus 1 less than or equals to a of I plus diff. So what we have done is we respected two conditions, okay? We respected the above conditions once. We have only respected these conditions. And then we are trying to respect this condition, okay, which is a of I less than or equals to a of I plus 1 plus diff of I. So we have went like this and then we have only respected these two conditions and then we have done that. After doing that, now we are trying to come from this side and trying to respect this condition. That's why we're trying to bring that down, a of I, if it was very big. And once you bring that down, maybe that affects something else and you have to bring that down too. But how do we prove this works well? I don't know. I cannot solve such problems that well because I don't guess much, right? I get it, but we have to prove very clearly things. When we prove, we have to prove them very clearly. Maybe, but I'm tired today, bro. I don't know, bro. Bad action travels. I don't know. I got a hint from someone. I know you're talking to someone else, but I'm telling about me. How to sleep or how to eat something. Bye, guys. Try swimming. Why though? Yeah, in next stream I'll try. I got hint from someone over here. Someone told. It's still not easy. I want to prove things, but how can I prove it here? We're respecting two conditions and then we're respecting the other condition. Da, 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 da. How are you guys doing in general? CG is important. CG is important. What's my weekend plans? This weekend I don't have much. Next weekend I have to go out somewhere. Not go out. I may do something, but this weekend I don't have any. Morning I spent 5 hours, 5 fucking hours, just after waking up on ICPC. What do we do, guys? Should we play chess? That is a brute force, right? That's a direct brute force problem, right? The only thing it has is you can see from here to here as from here to here and then summation of these things. Let's try some code forces problems, guys, then. Can we solve at least one problem? This one seems tempting. But why they have to be difficult? The master creates a composition of n colored mosaic elements. Each element is painted in one of m possible colors. The colors are numbered from 1 to m. The master arranges the composition in such a way that it can be represented as a tree. The composition is considered beautiful if for each color array the total degree of all vertices of color array has specified parity mask I, where Mask is an array of m numbers 0 or 1. The total degree of vertices of color I. This is a nice problem, I guess, right? They are asking us number of different trees possible. And after that, if you look at this color, it's a nice problem, but I don't have energy now. It's a nice problem because we have colors fixed. And then you have to see number of different trees that you can form with them. Number of different trees. So what, chess? I'm bad at chess too. I don't want to play chess. My fire's lost. Why too many grids? You have a grid of size n cross 3. You want to paint each cell the grid with exactly one of the three colors, red, yellow, green, while making sure that no two adjacent colors have the same color. Given n the number of rows of the grid, is it n into 3? It's an easy problem, I guess, right? Because if it is, you have to only see that, you only have to see that. So, number of different possible rows is small. Total number of, so what is small? What is simple in this? What is simple or small? Number of different row configurations is small, right? It's either red, yellow, green, or red, green, yellow. You have red, green, red. You have these possibilities. Okay, some get disqualified because they may be same or something like that, and you can see if this is compatible with this or not. This is compatible with this or not. So if you have number of things ending with this, ending with this, ending with that, you can try to check for this number of previous things which are compatible with that. You can get their sums. And n is small. Even if n was very large, I think we can do this problem. Even if n was very large, even if n was very large, maybe you can use some matrix representation and then do the problem. But now as n is small, we can do the problem. Let's just make it 0 1 2 instead of this thing 0 1 2. So So for row 0, let's say, should we write these three things like this, or should we try to write them as configurations? Let me write them as configurations itself. Vector int possible things. Okay. If I not equals to j and j not equals to k, pos dot pushback of ijk. So now we have possible things, right? We can leave this, or should we have that? We can have that too. So this is possible, okay? I won't have DP, I'll have map. What I mean by that is like vector int represents configuration. Okay, given this configuration, ending with this, what how many different possibilities are there? That will be given to us, okay? So if you're not understanding what I mean, for I, it only depends on I minus one's end. So how do you represent everything that are ending with this configuration? The previous configuration should be compatible with this configuration and ending with that. So it's that simple, okay? So if row is one, only one possibility, right? So now we have to do from I equals to 2, I less than or equals to n. What we have to do is for vector int f in pos, like among all possible configurations, okay? Let's just make it temp dot clear off, and let's store things in temp of f equals to 0 for vector int g of pos, okay? How do you say if two things are compatible? Bool com- compatible or okay. Okay is enough for us. Big words. Why compatible? Girls will use such words. Girls will use such big words like I don't think we are compatible. Whereas okay or not okay, yeah. Simple. Where are we? F of 0 not equals to g of 0 and f of 1 not equals to g of 1 and f of 2 not equals to g of 2. If any of that, not of. Okay, this is right. So now the previous thing, if the previous thing is not compatible, previous thing is okay. If previous thing is okay with us, what we can do? Temp of f plus equals to dp of g. And then I'll swap temp and g. We have to return everything sum in gp. Int answer equals to 0 for vector dun, 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 dun. F pos Where are we? Answer plus equals to dp of f. Answer reminder equals to m. Return m answer. This should be working, right? Okay, okay. What the fuck? They're really doing that. They're really doing this shit. Please try again later or subscribe to premium for shorter wait times. These people are too greedy. I mean, if I if I if I see this thing, if people are like me, we will all collectively think these people are asking us money. Let's just let's just let's just ban them, or let's just like not use their site at all. We have to be like that. I don't know. You people are too greedy for jobs. Someone told like you get jobs if you do lead code, and then you all are like lead code, lead code, lead code. Not ban. What was the term? Abandon? I don't know. We got this. We only get this. How much money do we have? How do you get more? How do you get hoodie? Can I just compete and get this? I'm sleepy, guys. In an hour plus. I don't think he did it in an hour plus. You're doing too much. Maybe because he's LGM level right now. Maybe it's possible. Okay. You have to figure things out. Can you tell how Dominant after reading the question just instantly get the solution? He doesn't get, even if he's getting instantly solution, he's doing some things, he's observing some things in the question which are obvious after solving many, not even after solving many questions. He can follow some rules very properly. Even that can make him solve very quickly compared to others. Okay, if you can follow some rules very well, like if you can follow some rules very well, like not going into wrong directions and not wasting time with many such rules, you do good. It's all about doing simple things. If you can do simple things well, you can do good. Okay, it's not like we don't know how he is doing, or he's accessing something we cannot access. It's not like that. Like if you can learn to use your brain well, you can do better. Even if I do that, I can do better. I never focused on speed much somehow. Maybe I should. So guys, let's try easy problems. Speed force 1200 to 2200. 1200 is too much. 1400 to 2200. Can we speed force this shit? Damn. I'd solve problems. I cannot solve some problems somehow. I just cannot solve. Okay, this one was done. Got hacked. Okay, my D2 was accepted. I remember this. Let's try this problem. This I have fucked up in contest. I don't even absolve. I was doing something random. I know Satyam a bit. I know him like we have been together in ICPC or in general to I talk to him. He's on my group too. I've told you how, okay? What you gonna do now? Not so terrible coder. Be terrible at coding. Chicken jockey. It's a joke, it's a meme. I don't remember all, but I remember some. I remember somehow too well. I mean, I don't remember problems. See, my way of trying is zero memory. Like whenever I try a new problem, I try to approach it completely fresh. I don't try to use something I know. Okay, you have to observe that. Like I try to go from very beginning. If I try to take a new problem, I never try to see if I have solved something in the past. I have to get some confidence. Otherwise, I will fuck up the next contest too. I don't know. I get scared of easy problems more than difficult ones. That's just a damn LLM training. It seems Buggy's feature. How one is too easy and the other one is too difficult. Oh, okay, that was not 1300. This was 1300. This is just 28. Solid code easy for confidence. Rainbow strategy might be good. Bye, guys. There are more viewers when I'm doing nothing, when I'm doing slop, like when I am not like that, but unnecessarily thinking I cannot solve some problem in between contests is worse. Unnecessarily thinking I cannot solve some problem. Have I done that here? What have I done? Only three problems. Why was I not able to solve this? I was not able to solve this. I can never upsolve. If I read the solution, will I understand it? On D. I thought something will work. Something like some greedy, P or greedy, I don't know. Yeah, I have written this in contest. What the fuck is this? How is that an easy problem though? It's not easy, right? I've seen that is happening. But then I thought it is too much. I thought like doing this is too much. Okay, if you can combine all these prefix, but you cannot combine these two things, whatever happens, then is greedy better? Can you say always greedy is better? Trying to take something that is okay as a solution was trying to take the first prefix that maximum prefix and remove that seems not too difficult to guess because if that is not connected, then you're trying to do something on that so that you're not connecting this. Maybe this will connect it to that. So that maybe this will get connected to that. But I was not able to say even that is good. Like even now, I'm not able to say that greedy is correct. Like I should guess solutions a bit. I was thinking about this problem. Random solutions on that. Why do I have more viewers when I do slop? Like when I don't do anything? I don't, bro. I'm sleepy. I don't understand questions that well. I don't like the term first principle because I never used that. Okay. I just don't remember much. That's it. I can remember much. I just don't try to use memory while solving problems. Is my maybe I don't know. I do something. I don't know. I'm doing bad these days. Very bad. What can I do to do good? I recently solved one 2700, but still I feel I'm not able to do some problems. Not able to guess. This one I have solved live. I guess right. It's an AK in this then. Was it in contest? Nope. I think I should just sleep properly. That's the reason. Even now, because I don't have energy, I don't have sleep, proper sleep, I think I still don't have. Because of that, I feel like I cannot do anything. And I'm giving contests when I'm not having sleep. I think if you have good sleep, we can have confidence, we can just do them. Now, bro, it's because I'm not sleeping. The thing is, I was doing company work before too. I was doing company work here too. Even here, I was doing even here. This is just I came unnecessarily down. In January itself, I will go back to IM. Okay. So we have to grind for that. We have to increase speed, guys. We have to speed force. We should not waste time. Let me speed force here. Removal of a sequence. Okay, this was done. Let's speed force some more problems. You were given two binary strings S and T. You're given two binary strings S and T, each of the same length, and you are allowed to perform the following operations. Pick two indices such that substring is a palindrome and flip its bits, and flip all bits in substring S, L, comma, R. Binary strings. We have two binary strings. You're allowed to perform the following operation, and in S it should be a palindrome, and then we flip that. It will remain a palindrome. The goal is to finally make S equals to T, performing any operation at most possibly none. Substring S is continuous. Substring means changing 0, comma 1. Okay, maybe it's always if it is possible, it's possible in 2 and moves. Okay, but still, when is it possible? Keeping operations aside, operation is reversible. Means it's still a palindrome. You can go back. There are equivalence classes. If you keep operations aside, again. Okay, probably if it is possible, you can do in 2 and operations. Probably, okay. So what remains constant? If a string is palindrome now, it will be palindrome forever. If a substring is palindrome now, no, wait a minute. That we cannot say because uh, this whole thing is a palindrome now, but it might change if you flip this thing, right? So what remains constant? They are calling it a palindrome, but what remains constant here? You can flip 0, 0, 2, 1, 1. Okay, you can do that. You can flip 0 to 1. Really? Is the palindrome having a minimum size? Yeah, it's having a minimum size. What about 0, 1, 0, 2, 1, 0, 1? Because I think it has too much freedom. Palindrome has too much freedom. Like palindrome, they say it a palindrome, but logically, I don't think palindrome helps us a lot. You can flip anything. I think it's like that. What all can you flip? What all can you achieve? What remains constant in this kind of operation? You can flip adjacent two things that are same. Okay. Okay. With just this thing, what can you say? Two zeros can turn into two ones. So it's like even or odd doesn't matter kind of thing, right? Because with this thing itself, you can probably move all of them before, and then it will become 1, 0, 1, 0, 1. You can do that for sure. Odd components, you have odd components, let's say. Okay, you can take these two things and you can move to there, and then you can move all of them before. Okay, now again you can take all the even things, like even zeros, you can make them even ones, and then you can move them forward. Okay, you can always do that. You can always do that. So it can be like this. Just using this kind of flips, it can be like this. And now 0, 1, 0. Can you change that to 1, 0, 1? Let's say without loss of generality, have something like that. Can you change 1, 0, 1, 0, 1, 0, 1? Can you change this to 1? 101 101. Now because again this is even, you can change that to, these are reversible operations, okay? 0 0, and you can change this four zeros to 11 11. Even parity doesn't remain constant because you can change 10 to 11, right? By involving other things. Yeah, by obviously by involving other things. So when is it impossible? Is it even impossible in any case? Can you always make them? In how many operations can you come here? I think you can always try to do, try to match, try to go and find as long as you can match these two things. Okay, you can definitely find a palindrome if you keep going. Maybe the next thing is equal, then you will find it, and if you get the next zero, then you can flip these two so that they will match. You can keep doing that. If you keep doing that, you can always find a palindrome. You can make all of them equal, except the last one thing. Okay, if you just follow that in O of n operations, okay, in n operation, in n minus 1 operations, and then you will encounter a place where this is 1 and this is 0, but then you don't have the next 0. As long as you have the next 0, you can flip both of them and you can keep proceeding. Okay, you'll encounter such a place where prefix equal, but this is not matching, but all of these are like that. Now what you do is, if the size of this is like double, if the size of this is like not just two things, and what I'm trying to say is maybe you can flip these two things to 0 0, and then you can flip these two and so on, proceed. Let's just have 1 0 and 1 1 at the big end so that you can always keep flipping. Okay, let's just have 1 0 and 1 1 in the end so that you can always keep flipping, and then you come till here, you matched all of this thing. Now if these two things doesn't match, I don't think it's never impossible, it's always possible, but we have to find some procedure. We have to go to something like all ones or all zeros, and from then we have to come back. If you can go to all zeros in O of n, the problem is done. Can you go to all zeros in O of n? Whenever you find a 1, try to find another 1, make both of them as zeros. You can keep doing that. You can keep doing that. As long as there is only one, you can keep doing that. Because if you see this one and see this one, you make them as 0 1 0 and so on. So you cannot, you will fail only when there is only one. You cannot do that. Okay, you came till here and there are no one after that. Only now you cannot do that. So you can come here in O of n operations. Operations are reversible. Okay, so if you can come here, you can go back to anything too. Okay. But now how can you make sure that you can make all of them as zeros too? You can likely flip all of them and then flip all of them. You can likely flip all of these things, okay, to ones and then flip all of these things to zeros. So you can make all of them as zeros in n operations and then you can just reverse them. That's it, guys. I thought this is too lame to do. I thought it will be more complex. My first simple idea was, so these golden rules are not like to give us positivity, like they're that shitty. The problems are that shitty, that easy. You can make all of them as zero and then you can go back. Okay, we'll try to follow this procedure. And you can do that procedure twice and you can reverse the lost n operations. Okay, if you reverse the lost n operations, what happens? From 0 it comes still here. Okay, from 0 it comes still here. So now how do you make 0? Whenever you have 1, you make them, but now you are here, there is no 1. Okay, there is no 1 and you are here. Either side will have more zeros, right? Either side will have greater than two zeros. Either side, because n greater than or equals to 4. Choose side which is having greater than two zeros, flip them, flip twice. So is it becoming n plus 1 operations is what I'm trying to think. Because then we will fail, right? We cannot do 2n plus 1 operations. We have to do n operations to go to 0. If there is something on this side, then we can do n plus 1. We can do 2. But if it was this one, only in this case you cannot do. If the last one was here, you might have already done that many ones. Okay, what will you do for this is you will start from nah, we want to just say one operation which should be possible to make things 0. So once you have one, your algorithm will try to find the next one and then it will just flip them. If you have some set of ones, you can flip all of them too together. Otherwise, you can try to do this. Try to find try to find something which is greater than size 1. Just find one thing which is having size greater than or equals to 1, and then keep doing, and then keep combining it with its adjacent, and then keep making it bigger, bigger, bigger. That will take n minus 1 operations, and you can use one more to make it 0. Try to take something which is size greater than 2, flip them, you'll have bigger thing, flip them, flip them, flip them, flip them. Even this is a procedure. Can we have simpler procedure though? But what if there is no such a thing? Then what can you do? Then you can try to flip all of them. Then you will get 0 0 1 0 1 0 1 0 1. And then try to flip again all of them. You'll get 0 0 0 1 0 1 0 1 0. You can flip all of these things. But this is also not that simple algorithm. We had simpler algorithms. Try to find the next one and then flip. I think what you can do is, when you know these are the only two ones, I'm flipping both of them, then it will become only one one. Only case that is left is one is being at the end. But will that never happen? Think about that. I think that will never happen. I think one coming at the end will never happen, because look at the case when there were two ones. I think when there were two ones, what happens is, I'm only worried about 2n and 2n plus 1. Unnecessarily worried about. I mean, I know, I mean, this was done, right? This was done. This problem is done now, but we just have to make it 2n operation. But I just want to find a simpler way to do it. She looks just like a dream, prettiest girl. Let's say I've removed all the ones here, and then you're here. Now let's say there are only two ones. Okay, now if there are only two ones, what you can instead do is, using these two ones, you can try to, okay, when there are two ones, you can do something. When there are two ones, if those two ones are adjacent, flip both of them to zeros. Okay, but if the two ones are having like this, now you have three things. So you can do, because there are three things, you can flip you can flip those three things, and if the middle thing is greater than one, then you can flip them to zeros. But if that doesn't happen, even in this case, you can flip this side, you can flip this side, and then you can flip this to zeros. So you have done two operations, and then it's being n plus 1. Guys, we need some. It is definitely possible to do in n plus 1, but we need some simpler procedure to do it in n plus 1. We need some simpler procedure to just do it in n operations. He looks just like a tree. I don't think it never happens. See, the only case we are worried about is one being left out. Happy New Year. Only case we are worried about is oops. I cannot show you people distance. Mm, where are we? Now it annoys me. Guys, we have to make all zeros and bring it back. How can we do that? I don't want to fail. So in this we can choose this, make them 1, make them 0. But will that be n plus 1 operations is my doubt. Will that be n plus 1 operations? Let me just submit. Let me just assume that part. I think we need a simpler procedure. If there was something which is of size greater than 1, then flip that, connect these two components, flip all of them, flip all of them, that would work. Okay. Otherwise, that would work in how many operations? N minus 1 operations. Okay, it will make all of them equal. Plus 1 operation to make it 0. Okay, let's keep that simple because flipping is also not that easy, right? So we'll try to find this procedure. If it was like this, what can you do? You can flip all of this thing, or you can flip this three things, so you form 1 0 1 1 0 1 0 1. Now you can flip all of that. Now you have something two times. You can flip that, you can flip this, you can flip that, you can flip that. She looks just like a dream. So now you have done one operation. Can you do in n minus one operations? Can you make all of them zero? You probably can because once you flip these two, two things will get connected, right? Not just one thing, but two things are getting connected on both sides. But what if the size is 4? One thing, only one thing got connected. Now you flip that as again. Now you flip that again. One operation, two operation, three operation. Maybe in four operations you can do that. But when did two things get connected? Initially all of them are different. After you flip that, one thing got connected. Okay, everything gets even if one thing gets connected, it's n minus one operations. Okay, but even after this flip, 1 minute, even after this flip, we get one thing that is connecting. So that's why there is progress. Even after this thing, there is one thing that is connecting. So in this case, we can proceed further. Even in this case, we can proceed further. So we are done, guys. In both the cases, we can proceed further. In n minus one moves, we can connect all. Plus one to make it zero. Okay, so if there is something of size greater than one, you can keep changing that, connecting, change, connect, and so on. If there is nothing, then you can try to flip first three things so that you will have these two things getting connected, and then you can keep changing those things. Okay. Okay, now we have the procedure. So once you have something of size greater than 2, what will you do? Let's say you have lengths, okay, L1, L2, L3, L4, up to so on. This is your thing. Once you flip that, both of these two will get connected, okay? So you have your range, let's say L comma R. You have to reduce L by L minus L2, increase R by R plus L4. That's easy, right? So we can proceed for this. We can proceed further. Okay, let's try to see if there is something of size greater than 2. Some component of size greater than 2. It's fine. I think you need not even do that. You can just check first four things. Okay. Else you can do one operation and connect two things and you can also form that. Okay, can we do more simpler? If first two things are equal, you can just keep changing them and forming bigger. Okay. If first two things are not equal, okay, first two things are not equal, then look at third thing. If they both are equal, you can connect. I mean, it's easy, but we are having too many options here to go further. You can just use this thing to keep connecting everything. But if first two things are not equal, then you can probably flip these three things. This is just annoying. I know what to do, but I'm just so if something exists, okay, greater than one. If g1 equals to zero, uh, we have seen that if g1 equals to zero, we can just do flipping these three things. Okay, zero, one, flipping these three things we can do. Then what do we have? Then what do we have? You have zero, one, zero, one, one. So you can change those two things. Sorry, zero, one, zero, one. So now you have these two things. Okay, you can flip them, flip. You can flip, and then these two will get attached. You can flip, and then those two will get attached. You can keep on flipping. So you can still solve the problem. You will flip one comma three, and you can clear, and maybe you can use this code again. I don't like writing like that. I don't like writing bad code somehow. Bad in the sense, if it is not like too good looking, I don't like to like that. I don't like to write that. Now I know the solution. Now I know the solution that you have to take L, you have to flip that, and you have to combine both sides. But I'm not liking to write that code. To have to keep one pointer here, keep two pointers for both of these sides, and we have to keep going. I'm not liking to write that like that. I'm not liking to write that code. It's simple, like it's not difficult to write, but Now this is after, right? I'm just not liking to write that. I mean, this problem is easy, but it has some difficulty. I think all problems cannot have small solutions. I guess. So now we have. So now we have pos L. Possible of L is number of things that have paused, right? Maybe it has a simpler solution because there are so many possibilities, right? I was not able to choose at all. So one, two, three, four, five. We are flipping four, five, and then we are flipping. How can five increase? Five doesn't have anything after that. Four, five, three, five, two, five. Here it was one and three, and then it will be after one and three. It will be 0, 1, 0, 0, 1, 0, 1. Now it should do three and four. Then it will be 0, 1, 1, 1, 1, 0, 1. Now it will be two and five. Four, five. Yeah, it will be 0, 0, 0, 0, 1. Now it will be 1 and 6 and 1 and 7. Yeah, it's working correct. I'm not able to talk much. See ya.